in this session, we'll be talking about mastering COQL. So in the previous sessions, we've had a few sessions on the COQL, Search API, Bulk API, Notification APIs, etc. So feel free to check out those videos. Now, coming to this session, mastering COQL. This is a continuation of the previous session we had on COQL. Just to get us all up to speed, this is the agenda for today. So today we'll be discussing what is COQL and when you should use it. This is going to be a very brief explanation of what a COQL API does. And then coming to the juicy part of the agenda today, we'll be discussing joins in COQL and the different types. We'll also be explaining the different joins with examples. We'll discuss subqueries in COQL and when you can use them, the different types of subqueries with examples. And we'll also see the execution sequence of a subquery. And we'll have a brief comparison between subquery and joins. And then last but not the least, we'll see how you can fetch more than 10,000 records in version 6 using COQL API. And from version 7 and up, how you can retrieve more than 1 lakh records. Now, coming to what is COQL. So as many of you already know, COQL stands for CRM Object Query Language. This is an API that is based on the SQL syntax. So essentially, you use COQL to query for records and other cross modules. How SQL uses table names and column names, COQL API uses module names and module API names and field API names. So when should you use COQL? When you want to query for records from cross modules. Let's say you have contacts and the contact has a lookup field that looks up to the accounts module. In that case, there is a cross module relationship between accounts and contacts. So when you want to fetch not just the contacts, but also the details of the accounts, then you can use COQL. COQL supports a wide range of comparators and operators, different field data types. So it allows you to perform complex filtering. COQL also allows for nested conditions to fetch records based on different date ranges, etc. Let's say you work in analytics and you use a lot of aggregate functions. So COQL will be your go-to API because COQL also supports aggregate functions such as sum, count, minimum, maximum, average, etc. Because COQL supports nested queries, you can fine-tune your data retrieval using COQL. Coming to this, joins in COQL. What are joins? Generally in SQL, join means you're establishing a connection between two tables using a field or a column that is common to both tables. Similarly, in COQL, you can also establish a join that allows you to connect two modules that are linked by lookup fields. Let's take the example of contacts and accounts that I mentioned earlier. So if account is a lookup field in the contacts module, then you can essentially use the dot operator. So you use the dot operator to establish a join, and then you can use this field API names and module API names to fetch data from accounts when you're querying for the contacts module. So one example is this, account name dot parent account. For example, account name will give you the name of the account. If you want to get the parent account of that account, which is again a lookup field to the account module itself, then you have to use the dot operator like account name dot parent account. So this will get you the details of the parent account that the account is associated with. So this is all about joins. So basically, joins allow you to establish a relationship or fetch records between cross modules that use lookup fields. Now, the types of joins that are supported in COQL are base join and select column join. Coming to base join, whenever you have a join, whenever you use a dot notation in a clause other than the select column, other than the select query, select statement, then it is called a base join. That dot operator can be in the where clause, order by clause, or group clause. So when you use in any of these clauses, then it is considered a base join. So let's say you have, when do you have to use a base join? Let's say you have a module that has, let's say 5 lookup fields that look up to 5 different modules, and you want to fetch, the records from all the 5 lookup modules. In that case, you can use a base join. You can just use the, let's say it's contacts.vendors or contacts.accounts, contacts.products, etc. So you can establish a base join. You can apply criteria in the where or order by clauses, and then you can establish a base join and then fetch records. So here I have given an example of a base join. Here in my select statement, I'm querying for the records from the contacts module. So contacts my base module in the from statement, and then in my select statement, the select columns are last name and email. So I'm fetching last name and email fields from the contact module, and in my where clause, I'm giving the condition. As you can see, I have used the dot notation to establish a join. So in my contacts module, let's say account name is a lookup field. So I'm trying to get the parent account of the account that the contact is associated with. Let's say the contact is associated to an account called Zilker. So I want to get the parent account of the Zilker account. So how do I do it? So in my where clause, I have used the dot notation, account name dot parent account dot account name. So this will give me the account name of the parent account, and then I want to get only those contacts whose parent account of the account is king. So essentially I'm applying criteria here in my where clause. So I'm establishing a base join here because the dot notation is there in the where clause. uh, you have to use a base join when you have let's say when you want to establish up to 5 joins per query. Now, what do you do when you want to establish more than 5 joins? In that case, we have introduced something called the select column join in COQL. So as the name suggests, select column join is used in the select statement itself. So here you want to query the main module, and you can fetch the fields from the related modules as needed. So here in a select column join, you can have up to 15 select columns in a select statement. So here, as you can see, in my previous base join, I have the dot notation in the where clause, whereas in the select column join, I have the dot notation and I'm establishing a join in the select clause. So here my base module is contact, which means I'm fetching records from the contacts module, and the fields are last name, whereas owner.profile and created by .role are essentially establishing a join between contacts and the users module. So here I want to get the profile information of the owner of the contact as well as the role of the person who created this contact. So here I'm establishing a select column join. So I'm establishing a join in the select statement by using the dot notation in the select statement. So this is about select column join. So let's try this with an example. Now, so I'm using Postman here. Let me just try to refresh the tokens. So I have a self client here, and I have set up authorization from the Postman collection. So here I have just refreshed my token. So I have a new access token here, and then coming to the COQL API. So I'm using version 8 of COQL API here. So the request URL is CRM V8 COQL, and it's a post request. So in my authorization, I have the access token here. Coming to the body, as you can see, this is a base join. So by base join, I mean I use the dot notation in a clause other than the select statement. It could be in the where clause, it could be in the order by, or it could be the group by clause. So here I'm trying to fetch last name and email from the contacts module, and here I'm applying condition in the where clause here. So the parent account should be Zilker. Let's just try this. So I have a set of records here that have the parent account as Zilker. So these contacts have an account whose parent account is Zilker. So I have close to 7 records here. So this is a very simple base join. Coming to the select column join, this is the same example I showed in the slide. So I'm selecting last name, owner.profile, created by .role from contacts where email is not null. So here I'm establishing joins in the select column. So this is a select column join. Can you try this? I'm getting the profile information of the owner of this contact, the last name of the contact, and also have the ID, which is given by default. And then I have the role of the person who created this account. So I have close to 41 records that match this criteria where the email is not null. So this is about base join and select column join. So to summarize, base join is when you have the dot notation and you establish joins in either the where, group by, or the order by clauses. And in a select column join, you establish joins in the select statement of your query. Next are subqueries. Let's say, let's just consider this use case. You have the contacts module, you have the accounts module, and you also have the vendors module. Now you want to fetch the contacts whose email is not null, the contacts that have an account, and those accounts should be connected to a vendor who is certified compliant, who is in a list of countries in the Europe, in the Europe in one of the European countries, and should also have a GL account that is related to sales. So here we have a lot of conditions to apply. So when you use a single query and use the dot operators, there is a chance that you might exceed the limit of using joins. So in that case, what do? You use subqueries. So what are subqueries? Subqueries are nested queries that allow you to filter results dynamically. So the nested queries are essentially a select query, inside that another select query, another select query. So this is how you nest your queries so that you achieve the depth of filtering that you require. And you can also use subqueries when you want to filter module based on the criteria applied on the related module. So in the use case that I just said, contacts, accounts, and vendors, you are applying the criteria on vendors, which is a cross module in the accounts, and accounts is another related module in contacts. So you're applying the criteria in vendors, and then you're trying to fetch the records that match the condition. So because you're using nested queries, it enhances the filtering depth. So when you have a lot of conditions to apply, when you want to filter dynamically, then you can use subqueries. So each query can have up to 5 subqueries, and each subquery can fetch up to 100 records. Let's say the vendor's subquery has more than 100 records. Let's say it's at 200 records. So how do you get the other 100? It's simple. Just like any other select query, you can use the limit and offset options to paginate and get the required number of records. Another advantage of using subquery is that it improves performance by reducing memory usage. Now, benefits. Like I said, it is easier to simplify complex conditions because you essentially write subqueries, which is essentially another select statement inside your query. So the queries look cleaner, they are much easier to read, and it is you cannot make many mistakes here because the conditioning doesn't become very complex, and then you avoid repetitive joins, and then it is more powerful than standard filters because it allows for nested filtering, and it reduces multiple API calls, and you can retrieve up to 100 records per subquery. Let's just try this out with an example. So I have an example for a single subquery here. As you can see, this is my select query. This is my select statement. Inside this select statement, I have another select statement. So what am I trying to do exactly in this query? I'm trying to find contacts whose accounts have never closed the deal. So in this case, I have to apply my filter in the accounts module as well as the deals module. So for the filtering of deals module, I am using a subquery to filter out the deals whose stage is not closed one. So when there is a deal that has not in the stage closed one, I am getting all the accounts. So and from these accounts, I'm getting the matching contacts. So when I try this, I have a set of contacts. So these contacts have accounts that have never closed a deal. So as you can see, this is a subquery inside the main query. This uses a single subquery. So essentially, just like how we use the select statement in a query, I'm using the same select statement in a subquery. So this is for a single subquery. Let's try multiple subqueries now. So here, this is the use case I talked about. I have contacts, I have accounts, I have vendors, and I'm trying to find contacts whose email is not null that are linked to accounts whose vendors are in Europe, essentially in one of these countries. And then those vendors should be marked compliant and they should be tied to accounts, GL accounts that are related to sales. So how am I achieving this using nested queries? As you can see, this is my main query, and in this I have 2 subqueries. So the innermost subquery is where I've applied my criteria. So first I'm applying criteria for the vendors module, where I'm filtering out only those vendors whose country is one of these: Netherlands, Germany, France, and the vendor should be compliant. So is compliant is a custom checkbox in my vendors module. So is compliant should be true, and the GL account should be related to sales. I'm using the wildcard character here because the GL account can be sales related to hardware, sales related to software, or anything else. So I have a wildcard character here. So here I'm filtering out vendors in this subquery, and then based on this, the response of this is passed to the outer subquery here. So based on these vendors, I am filtering out the accounts. So the accounts that have vendors that match this criteria. This will be my second subquery. And then the results of this query will be passed to the outer query. Let's just try this out. Okay. So I have three contacts. So I've fetched the full name, account name, email, account name dot vendor dot country custom. So country underscore custom is also another custom field in my vendors module. So as you can see, I have the contact's full name, email, and then France. The vendors are the criteria is applied on vendors. So here this vendor is in France, and then I have an account, and this is the ID of the contact. So I have 3 records. 2 are from the vendors are from France, and 1 is from Netherlands. So how does this happen? So first, the innermost query is executed. So here the innermost query is the one that I'm applying criteria on vendors. So this query executes first, and then the results of this query are passed to the outer subquery where I filter the accounts, and then the results of this is passed to the outer query where I filter the contacts. So this is how multiple subqueries are executed. So the execution sequence, like I explained right now, we subqueries follow an inside-out evaluation, which means the innermost query is executed first. So in this case, the innermost query is this at a sequence of 0. So this is the 0th subquery. This will be executed first, followed by the subquery sequence 1, which is the subquery number 1, which filters out the accounts, followed by the main query. So this will be the execution sequence. So inside out evaluation, subqueries are executed first, and then the result of the subquery is passed to the outer query. So this ensures that you always filtered results are passed to the outer queries. Now, I said subqueries optimize memory utilization and performance. How? Let's say for the same use case, if you have to use just a flat query using joins, then the query, number one, the query would be complex. Number two, there is a possibility that you might uh, exceed the joins limit. So, and what happens is, let's say there are 100 matching vendors. For every 100 matching vendors, each account will be processed. And then for each account with matching vendor, all the contacts will be processed, which means the query takes quite some time to execute. Whereas you use subqueries, so first the innermost query executes, which means only the vendors is filtered first, and then only the matching results are passed to the outer query, which means only the matching records that satisfy the criteria will be compared with the criteria for accounts, and then the results that match this subquery only will be passed to the outer query. So this, apart from having a greater depth, the query is also quite optimized because the query actually compares only what is necessary instead of just going around and around comparing with all the other criteria that is there in the query. So this is how subqueries optimize memory utilization and performance. So this is a brief comparison about subquery and joins. So these are the aspects that I'd like to compare subquery with joins. So the first one comes is the purpose. So when should you use subquery? When you have conditional filtering, when you want to apply a lot of criteria on your in a query, and then you want a lot of conditional filtering to happen, you have different stages of filtering, then you can use a subquery. Whereas if you, let's say it's a very straightforward way of fetching just the related fields, then you can use joins. The structure and execution sequence. So subquery, like I said, subqueries are nested queries where the innermost query is executed first, whereas joins, it's just a flat query with just the dot notation. Performance, when we talk about performance, if you have conditional filtering, if you have a lot of depth, then subquery does better at filtering out logical statements. Whereas if you use joins, where it is just the data that you want to fetch, then you can use joins. So a few things that you need to remember when you're using subqueries and joins. Subqueries, it is allowed only in the where clause. If you see here in my single subquery, I have used the subquery only in the where clause. Similarly, in my multiple subqueries, I have used it only in the where clause. So subqueries can be there only in the where clause, and then only one select column is allowed in the select statement of each subquery. This means here I'm selecting ID from accounts, which means this ID is the select column from the accounts module. So if you're using a subquery, then you can only select one column in your select statement. Similarly, in this subquery, you can only select one select column. So here I'm selecting ID from vendors. So this is another thing that you want to remember when using subqueries. And like I said previously, each query can have up to 5 subqueries, and each subquery can fetch up to 100 records in every API call. If you want to each subquery to fetch more than 100 records, you can use the limit and offset in the subquery. A few points to remember about joins is that when you have a lot of conditional filtering to be done, then joins, the query itself becomes very bloated, and the syntax becomes very complex. And then you can have a maximum of up to 5 base joins. When you're using base join, you can have a maximum of up to 5 joins, and if you're using select column join, you can have a maximum of up to 15 joins. So this is all about queries, subqueries, and joins in COQL API.